Hello students, in this video I will go through exercise U5A01B2 where I will be dilating a line on a coordinate grid. So these questions in this exercise are all pulled out of either the Regents or sample Regents that the DOE has issued, that New York State has issued. So let's take a look at this. So this is 2014 sampler, which was the sample test that they gave on the first year that the geometry Regents was published, so or at least the Common Core Geometry Regents was published. So question 3 of that exam, it says that the equation of line H is 2x plus y equal to 1. Line M is the image of line H after a dilation of scale factor of 4 with respect to the origin. What is the equation of line M? Now, you can do this in two ways. One is you can try to draw this thing out and then try to figure this out logically. I will do that for maybe the first one, and then we're going to try to do this algebraically, because it all becomes very, very similar. So I'm going to rewrite h in terms as y in terms of x, so it's y is equal to negative 2x plus 1. And if I plot this thing out, you're going to see that I have a line that looks like this. And we're going to be dilating this over this point, over the origin. So when we dilate something over the origin, all of these points are going to be multiplied by a factor of 4. So I want to multiply 0, 1 here by a factor of 4, and I will end up over here. I want to multiply 1, negative 1 by a factor of 4, and I'll end up at 4, negative 4. So this is going to end up being my new line with a dilation of factor of 4, which is kind of ironic to think about, because a line goes on forever. It would be more appropriate for them to say dilate the line segment, but no, they choose to say dilate the line. So anyway, this line that's been dilated, right, will always end up having the same slope, so the two lines are parallel. So m is equal to negative 2, and you can see here that the y-intercept is 4, so the equation will be negative 2x plus 4. So that would be option 2. Okay. The line y equal to 2x minus 4 is dilated by a scale factor of 3/2. So keep in mind that the slope, and it's dilated over the origin, of course, the slope will always be positive 2, so that immediately eliminates these two things here. So the y-intercept is at negative 4. If I dilate this length by a factor of 3/2, where will negative 4 end up? It will end up at negative 6, because the length of 4 times 3/2 will be 6. So the equation will end up being option 2 here. The line 3y is equal to negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? So again, y is equal to negative 2/3 x plus 8/3. That's the equation. And we're dilating is transformed by a dilation centered at the origin. Which of these could be the line that's been dilated? So I need to have a line with the same slope, in other words. Okay, so which one would that be? It would definitely not be this, because if I subtract 3x from both sides and divide by 2, I will not end up with negative 2/3. It will definitely not be this guy, because if I subtract 2x and divide by negative 3, I will end up with a slope of positive 2/3. So the only one that would make any sense is option 1. Okay. In the diagram below, triangle ABE is the image of triangle ACD after a dilation centered at the origin. The coordinates of the vertices A, B, and C, and D are and E are given. And what do we need to do with this? The ratio of the lengths of BE to CD is. BE to CD is. Now all we got to do, because it's been dilated, everything about this is going to be proportional. So if you look at this, this is a length of 4. This is a length of 6. So the diagram ABE is the image. ABE is the image of ACD. So that means we went down in size. The scale factor is going to be 2/3. 4/6. 2/3. So it will be this guy right there. Even though it's asking for BE and CD, all of these parts will be proportional. So look, check this out. This guy right here has a length of 3. And this guy right here has a length of how much? 4.5, right? Let's see here. If I multiply 4.5 by 2, I will get 9, right? So 3 over 4.5. Is this the same thing as 6 over 9? Yes, it is, because if I multiply top and bottom by 2, I get 6 over 9, right? And then if I divide top and bottom by 3, isn't that 2/3? So DC and EB will also share the same proportion. All right. Let's take a look at the next one, next page. The ratio similarity triangle boy to triangle GRL girl is 1 to 2. So that means we are dilating. We're going from 1 to 2 times the original. If BO is equal to x plus 3 and GR is equal to 3x minus 1, then the length of GR is, so BO, GR is going to be twice as big as boy, by the way, right? So that means BO is going to be half that of GR. And if that's the case, then x plus 3 is equal to 1/2 of 3x minus 1. I want to multiply both sides by 2. 2x plus 6 is equal to 3x minus 1. Subtract 3x, I get negative x. Subtract 6, I get negative 7. X will equal to 7. And we need to find the length of GR. So to find GR, all I got to do is just substitute 7 back in here. 3 times 7 is 21, minus 1 is 20. So that would be option 4. All right, June 2016, question 2. A 3-inch line segment is dilated by a scale factor of 6. Now this makes more sense. A 3-inch line segment, notice they didn't say line, it's a line segment, is dilated by a scale factor of 6 and centered at its midpoint. What is the length of its image? Well, regardless of where the center of dilation is, the length will always be multiplied by whatever the scale factor is. The position of where the center of dilation is, the location of the center of dilation, has absolutely no effect on the image itself, or the size of the image itself. It does, however, have impact on the location of the image, but it has no impact on the size of the image. Anyway, so if the original was 3 and we have a scale factor of 6, that would be 18 then, and that would be option 4. Line N is represented by the equation 3x plus 4y is equal to 20. Determine and state the equation of line P, which is the image of line N after a dilation of factor of 1/3. So 3x plus 4y is equal to 20 can be re-expressed as y is equal to negative 3/4 x plus 5. Why am I rewriting it in slope-intercept form? Well, that's because I wanted to know what the y-intercept is. Because this thing is being dilated over the origin, it says that, where does it say that? Oh, it's not being dilated over the origin. What am I doing? Okay, so it's being dilated over the point, centered at the point 4, 2. So what I'm going to do, okay, is I'm going to plot this thing, because the rule that I gave you is slightly different here. We do need to plot this out, okay? So 5 is right here. We're going to go down 3 and over 4, which is right there. So this is the line, okay? And then 4, 2 is located right here. It's on the line itself. Okay, so if that's the case, after a dilation of 1/3, what is the question is, what is the question asking for? Determine and state the equation of the line P. Well, because the center of dilation here is on the line itself, the equation of the line will be the same. It's going to be no different. It's going to be absolutely no different. So the equation is, once again, 3x plus 4y is equal to 20. This is my answer. So imagine this, right? This line goes on forever in either direction. And this being the center of dilation, when I dilate this line, the line will still be, the image will be on top of this line, which is the same exact line. So it's no different. All right. January 2018, the line whose equation is 3x minus 5y is equal to 4 is dilated by a scale factor of 5/3, center at the origin. Which statement is correct? So keep in mind, the thing that will always be true is it will have the same slope. Let's see if that is going to be in one of the options here. Let's read number 1. The image of the line has the same slope as the pre-image, but a different y-intercept. That's it. This is it. It's the very first one. The image of the line has the same y-intercept as the pre-image, but a different slope. This is never true. It will always have the same slope. The image of the line has the same slope and the same y-intercept. That's not necessarily true. If the point of dilation is on the line itself, then that would be true. But in this case, it's not, because the point of dilation is over the origin, and the line does not pass through the origin. And number 4 here, option 4 here, says the image of the line has a different slope and a different y-intercept. That's not true, because it never has a different slope. Okay. August 2018, question number 30. Aliyah says that when the line 4x plus 3y is equal to 24 is dilated by a scale factor of 2, center at point 3, 4. So the equation of the dilated line will become that thing. Is Aliyah correct? Explain. Well, I am not sure, but the thing is, the slope certainly looks right. The center of dilation is located at 3, 4. I'm going to plot out this equation here. So y is equal to negative 4/3 x plus 8. So if I plot this out, that's at 8. I'm going to go down 4. 1, 2, 3, 4, and over 3. 1, 2, 3, 4, and over 3. I have this. And because I am dilating this over 3, 4, which is the line itself, then therefore this will be no different. The dilation will be no different from the original. Okay, so Aliyah is actually wrong. Aliyah is incorrect. The dilated line is the same as the original. And the reason for that is because the point of dilation is on the line itself. A line extends forever. So the new line will be on top of the old line. which is the same line. Okay. Next, what is the equation of the image of the line y equal to 3/2 x minus 4 after a dilation of a scale factor of 3/4 centered at the origin? So all we got to do, it's going to be the same slope, but we're going to dilate the y-intercept here by a factor of 3/4. And if we multiply -4 by 3/4, we'll end up with -3. And which option has that in place? It's this guy right there, 3/2 x minus 3. The line -3x plus 4y is equal to 8 is transformed by a dilation centered at the origin. Which linear equation could represent its image? So the line -3x plus 4y, dilation at the origin. So the scale factor is not stated. However, based on this, I can tell that the equation when I isolate y is 3/4 x plus 2. So I'm looking for a line that has the same exact slope of 3/4. So immediately these things are out of the question. And that's out of the question. So the only one that makes sense is option 2. And that's it.